All right, guys, this is the lesson on 11.2 probability distributions. I'm splitting it into two parts because the second part will focus on expected value. This first is kind of a quick overview. There is one particular part about using the graphing calculator to find binomial probabilities that I think you'll find important. Quickly reviewing, we have already talked about mean, median, mode, and standard deviation on the calculator. That's a different lesson. So if you didn't watch that video, make sure you go back and watch it. It's stat, enter, and then put your data in, and then it's stat, right arrow over to calculate one variable stats. And the calculator found the X bar or sample mean for us. There is another kind of a mean called a mu that you would use if you were in AP stats, but we're just gonna, when we say the word mean, we just mean straight up average, and that's also called the X bar. And then range we have talked about. These are measures of spread, and the range is simply the difference between the max and the min. The variance is the square of the standard deviation. The variance is not on your calculator screen. You would have to take the standard deviation they give you and square it. And I'm not going to take time to talk about how they find all these, simply because we're just going to use our calculator, okay? So the standard deviation is the average amount by which the items deviate from the mean. And we will generally use the sample standard deviation, though both this symbol for population deviation and the S for sample are on your calculator. We would make sure we specified on a quiz. So real quick, this is 25 kids took a quiz, a 10-point quiz. So the range would be the difference between the high score and the low score. So 10 minus 2 was 8. To find the variance, they found the average, which is 7.44, and then they figured out how far each was away from that, above or below, and that's why they square them so that they all come out positive. So how far away, and they averaged about 4.6 away, and so then the standard deviation is the square of that, and it says the standard deviation was about 2.1. And next week we will talk about how most data falls within one standard deviation of the mean, and even more falls within 2 standard deviations either direction. So that's lesson 11.3. Come back later. All right. At the top of worksheet 8, it goes through the difference between discrete and continuous data. And it introduces this term called a random variable. It's simply the number, okay, that's assigned to a particular outcome. So if you want to know, the number of cars in the parking lot, the random variable is the number of cars. They will say the random variable X represents, and you just have to think of it as some number, okay? Discrete means that it is got to be a whole number. For example, if I ask you how many people are in a room, you're going to give me a whole number. Continuous is when data can be measured in smaller intervals. For example, a temperature, you could say it's 15 degrees out, or 15.2 degrees, or 15.25. So you could break it down smaller and smaller. So things like time and temperature and length measurements that can be broken into smaller pieces, like here it says miles, those are considered continuous variables. We're not going to spend a lot of time on this, but we might put a quick question on a quiz. I would choose a real obvious one if I did, but here's a couple examples. If you want to know the weight of a 15-ounce box of cereal, when you weigh it, it could be off by a little bit, but the number could be a decimal, anywhere close to 15 probably, but it is a continuous variable because you could measure it at 14.8, 14.9 ounces. Number of cars in a parking lot is called a discrete variable because you're going to only give me whole numbers of cars. So if it's whole numbers, it's discrete, think dots. And continuous means you can have a continuous number of answers, could vary. Here it says 2 more quick examples. If you have the amount of time it takes to get served at a fast food restaurant, time would be, got that thing turned on. Oh, what have I done? All right, I'm just going to keep going. The time would be a continuous random variable because your answer, the number you give for time could be in a decimal or broken down into, minutes and seconds or whatever. Attendance at a meeting, this is going to be discrete because it's a whole number of people. All right. 2 more examples off the top of your worksheet. It says the time it takes for our classroom to go from 68 down to 60 if we turn the heat off, and that would be continuous because we could say, it took about an hour, or it took 57 minutes, or it took 56 minutes and 32 seconds, whatever. Number of photographs taken by a photographer at a wedding, that would be discrete because that is saying that you would have a whole number of photos. You wouldn't have half of one. All right, then the majority of the lesson today is on what a probability distribution is. And this is really blurry, I'm sorry, but a probability distribution is when you take each possible value you can get for your variable, okay, and the probability that it occurs. So probability distribution has to have all the values for the probability from 0 to 1 so that they total 1. This is very confusing what I have just said, but let me show you an example. So a teacher put out an evaluation form, and the students were asked to rate a teacher's explanation of subject matter on a score from 1 to 5, where 1 was too simple and 5 was too technical. So according to this, the score from 1 to 5, and one student said they gave a 1, two students gave, a score of 2 was given by 8 students. A score of 3 was given by 20, and we add all those up, and there were 50 students that scored the teacher. So out of those 50 students, the probability of getting a 1 was 1 out of 50. The probability of getting a 2 was 8 out of 50, and the decimals are all down here. So if we move on, we can make what's called okay, off-power students are used to this craziness. All right, the probability distribution would look like this. So we took those decimals that were the probabilities of getting a 1, a 2, a 3. In other words, 40% of the students gave a 3, okay? And then we put them in this table, and this is called the probability distribution. So the probability of getting a score of 1, 2, 3, 4, 5. And you can also make a table. So in other words, the probability of getting a 4 was just over 30%, okay? Now, the kind of question I could ask given this would be, what is the probability that this teacher scored a 3 or above from a student? And then you would add these 3 scores up, and you would say that there's an 82% chance that the student scored a 3 or above. All right, so the mean of a probability distribution means, it says down here, to find the mean of a probability distribution, multiply each value by its probability, and then find the sum of the products. So let's go back to this example here. And it says, this was the score the student gave, and this is the probability of that score being given. So if we multiply those, we get the average. So this is the score times the probability, and that came out here, and then we totaled those all up. Therefore, the mean of this probability distribution is about 3.3, and the interpretation of that, which is important, would be since a score of 3 indicates the teacher's explanations were good, right on target, a mean of 3.3 indicates that on average students felt this teacher's explanations were appropriate, but they leaned a little bit towards too technical because it's a little bit above an average of 3. So this example, I believe, oh, is this example that's not on your sheet? Oh, it is, good. It's on 8A. It says, this is the number of medical tests that 15 randomly selected patients were given when they visited the hospital. So 6 patients, this is out of 15, 6 patients said they got 0 tests done, 5 patients said they had 1 test run, 3 patients said 2, and 1 patient said they had 3 tests run. So to construct a probability distribution, we're going to take the number of tests and we're going to find the probability of each, which would be 6 out of 15, or 5 out of 15, or 3 out of 15, or 1 out of 15. Now 3 out of 15 is 1/5, so that's a 0.2. 6 out of 15 would be twice that, or 0.4. But I'll show you what I did. Kind of cheated. I put stat edit, I put the information in from the chart. This was the number of tests, and this is the number of people who said they had that many tests. And then actually, to do this really quickly, I went up onto the title of this. I'm just going to hit clear, enter. Okay. And I said, you know what I want? I want you to take the numbers from list 2 and divide them all by 15. So you could certainly do that by hand, but I said second L2 down here, it's typing this into the heading now, divided by 15. So it's going to take all the numbers in list 2 and divide them by 15, and there they are. So 0.33 and 0.067 are the two that I didn't already have. Okay, I don't know what's going on with my pen, but we won't worry about it. Now it says find and interpret the mean of these, and then find the variance and the standard deviation. Well, this is, remember up here, it called this a frequency. We actually can use this list as a frequency list when calculating one variable stats. So if I put all these in the test score, or the number of tests run here, and the number of people who said they had that many tests, then if I want to do the one variable stats, so it's stat right arrow, one variable stats, we can use list 2 as a frequency list. When we did this lesson before, we didn't have a frequency list. So we do list 1, and then list 2 is the frequency list, and then we can just hit calculate, and it will give us these numbers for the mean and then the sample standard deviation down here. All right, I think I already have those on the slide. Here we go. So the mean was about 9.93, or on average about 1 test, and the standard deviation was also close to 1. So it's kind of the summary of what that means is not very exciting, because it says on average about 1 test was run, with most everyone getting between 0 and 2 tests. Well, that wasn't earth-shattering. We could have seen that from the beginning, right? Most everybody had either 1 test run or from 0 to 2 tests. So Anyway, but if there was a lot more spread out data, that information would be a lot more concise and helpful maybe. All right, this goes back to what we learned, the 10.5 video, which covered worksheet 7B, okay? So binomial probability, we're gonna expand on that today. So many probabilities, again, have two outcomes, success or failure. And so a binomial experiment is anything you can think of that way as having a fixed number of trials with only two possible outcomes, success or failure. And then the probability is the same for every trial. That's really important, okay? And the probability of failure is 1 minus the probability of success. And this was the formula we used to do that lesson, and it's on the reference sheet. And today we are finally going to talk about how to use this on the calculator, okay? So a binomial experiment, the outcomes are either success or failure. There is a fixed number of independent trials, and X is the number of successes, and the probability of success and failure have to total 1. So it says we can also use this on the calculator. All right, let me show you where that is. It is under, let me get out of this, okay. So it's under the vars key here, but you have to do second first. It's a distribution. Second, vars, okay. And then it is choice A, as I've shown on the side over there. Whoa, 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 sorry. Scroll down. I went too fast. There it is. Now, you will notice there is a Binom PDF and CDF. We're going to use the PDF only. If we were actually not doing e-learning, I would teach most of you about the CDF as well, which is combining the probabilities. But for the few questions we're going to do, it's easier to just do the PDF, the probability of each one, and then if you need to combine them, you can just add them together, because combine gets a little confused. So make sure you're picking choice A, not B. All right. So you have 3 homework questions tonight that are like this. They say determine whether this experiment could be a binomial experiment. So the results of a school survey indicate that 68% of students own an MP3 player, 6 students are selected at random, and we want to know how many are going to say they own an MP3 player. This is a success or fail question because they're either going to say yes I do or no I don't. And we have the probability as 68%. So the probability that they do is 68%. The probability they don't would be 1 minus that, or 32%, etc. This question says 5 cards are drawn at random from a deck to make a hand for a card game. The random variable is the number of spades. Now think about that. Each time you draw a card, it's either a spade or it's not a spade. So the success or failure is there, that part of it. But when you draw a card the first time, there were 52 cards. When you go back and draw another card, now there's only 51. So since the probability changes on each successive chance, it is not a binomial experiment. So here's a couple more. It says the results of a survey indicate that 61% of students like new school uniforms and 24% don't like the new school uniforms. So 20 students are randomly selected and asked if they like. The random variable is the number who say that they like them. So out of the 20 we ask, how many are going to say they like them? But the problem with this question is 61% said yes and 24% said no. Does that add up to 100? No, it does not. So therefore, this is not everybody. So it's not a success or fail. There's a probability that's unknown what they answered. So we can't use this one. It says you complete a test by randomly guessing the answers to 20 multiple choice questions that each have 4 choices. Now, That sounds like we're worried about out of 4 instead of out of 2, but a binomial probability means simply one of which is right. So the probability of success would be 1 out of the 4 is right. The probability of failure would be 3 out of the 4. And then it says the random variable represents the number of correct. So if you wanted to get 17 out of 20 right, you could figure out that probability. So this one is yes. All right, moving on. Another thing you will have to do on your homework for, I believe, one question is come up with the probability distribution. So this question says, a survey found 20% of Americans had visited a doctor in the last 6 months. 5 people will be selected at random and asked, did you go to the doctor in the last 6 months? And then we're going to make a probability distribution for the fact that 0 people say they went, 1 person says they went, 2 people, etc. So we are asking 5 people. So we could have nobody went, 1 went, 2 went, 3 went, 4 went, or 5 went. The probability they say yes is 20%, so that's P. The probability they say no is 80%. But here's where I'm going to jump to the calculator. Rather than using that big formula that we taught in the other video, we can use this. Let me go second vars. I'm going to go up arrow, I think it's a little faster, and find Binom PDF. Now, this is what it asks. The number of trials, the probability of success, and then how many successes we want to have. So, I should have put this somewhere else probably. Let me make it smaller maybe, and I can fit it in here. So when you use this, all it wants is how many trials, which we asked 5 people. P is the probability of success. So for this, the probability they went to the doctor was 20%. And then X value means how many people do you want to successfully say, yes, I went to the doctor. So we're going to start with 0, then we're going to change it to 1, then we're going to change it to 2, and so on, to fill in this chart. So it was 5 people, and probability of success was 0.2. And first of all, nobody went. So that's 0.327. I hope that matches what we have over here for bar 0, okay? 0.327. Now, I'm going to do it the long way one more time. Second vars, find A, 5.2, but this time I want 1 person to say they went to the doctor out of the 5. The probability that 1 out of 5 went is 0.41 almost, which is this bar. Okay, now I'm going to show you the shortcut. If you have an older or newer calculator, you can just arrow up and then go back and change the number of trials, this last number, to 2 people said yes, which would be this number. Or you can go second enter and then back arrow and make this 3 or 4 or 5. Whoa, what did I forget there? I did the wrong thing. Yeah, quit. Second enter 4 or second enter 5. Now, if I did this right, these are all the numbers already here in this little chart. Okay, then the question asks, what is the probability that at least 4 people said yes? And I'm not very fond of their answer because they added these 2 rounded decimals and got about 0.6%. If we actually added at least 4 people said they went to the doctor, would be the probability of 4 people going plus, plus the probability of 3 people going. And if you actually don't round the decimal, you get 0.0067. So this turns out to be closer to 0.7% that you're going to get when you, it's about a less than 1% chance that if you ask 5 people at random, that 4 or 5 of them would say, or 4 or more would say, oh yeah, we all went to the doctor in the last 6 months. All right, so here's the practice example. Survey found that 60% of American victims of healthcare fraud are senior citizens. So 60% chance that they'll be a senior citizen, 40% chance that they won't be a senior citizen, and 6 victims of fraud were chosen at random. And we're supposed to figure out how many of them were senior citizens. So, to make time go faster, I made up a little chart and put it in the little question already. So this is the number of victims that were senior citizens, and it could range from 0 to 6, and then the probability. So if I went back here one more time just to show you, and then I'll just use the numbers I have on this screen. It's second bars, scroll to choice A. This time there are 6 people we're asking, and the chance that they are senior citizens is 60%. And we would start with the chance that out of the 6 we ask, no one is a senior citizen, and that would be a very small chance, okay? 0.004. And then I did second enter, and I said, what's the chance that one of them said they were a senior citizen? And that would be this one. 2 senior citizens out of the bunch we asked would be, whoops, 1, 3, 8. There's about 28% here, 276 chance that we asked, and 3 of the 6 said they were senior citizens. 4 of the 6, 5 of the 6, and the chance that all 6 were actually senior citizens gets kind of small again. All right, then if we go back up to the question, it said, what is the probability that at least 3 of the victims will be senior citizens? At least 3 means 3 or 4 or 5 or 6 of them would be senior citizens. So what I did was on my calculator, I went back up and I actually added all of these decimals together without rounding just to get a better answer, and because they were all on my calculator screen. And after I said add all those up, I got 0.82. So the probability that at least 3 of the victims we talked to, at least 3 out of the 6 that we ask, is 82% chance that at least 3 of the 6 victims will be senior citizens. Remember, we were asking victims only of healthcare fraud. So the chance that at least 3 of the 6 are 82%. All right, I hope I explained that okay. So this is the end of the first lesson. You are to do these 3, which ask if it's binomial probability experiment, and then these, one of which is make a probability distribution table and interpret some things. So hopefully you can do those questions, and that is the end of video number 1.